Roger is visiting us from the Earth Systems Research Lab at in Boulder. It's a NOAA lab. He's the chief scientist of the physical science division there. Roger's background is in tropical meteorology, but very early on in his career, he went in the direction of trying to understand how do we use climate information and in related to hurricane risk or drought risk or flood risk. And he was really a pioneer in that, helping to establish some of the early institutional responses to this. Like in NOAA, he was instrumental in setting up the NOAA RISAs, which I don't remember what that stands for, but you can tell us.
Yeah, sure.
A national drought information system. He's been involved in lots of different assessment reports, IPCC 4 or 5, a special report on extreme events, and currently is doing a UN global assessment on I can't read my handwriting.
Disaster risk reduction.
Disaster risk reduction.
Okay, good.
And he originally is from the Caribbean, and he's going to talk about that work today as well. And with that, I will turn it over to Roger.
Thanks for having me. So, we're good. Going to extremes from risk to resilience, as Amy said. I have a diverse background. People like Kenny, myself, others got into this applied arena on climate very early, and so as a result, did a lot of things badly early on. So the idea here is, you heard a lot, this is, with the passing of Terry Jones, who did Life of Brian and all of that, you'll hear things, yeah, Monte Carlo, but also Monty Python. Let's talk a little bit about this. There's see, change is ahead. You don't need to be the Dalai Lama to know that. And a lot of people are implicated, from the Caribbean Institute of Meteo and Hydrology, folks at the Engineering Research and Development Center at the Corps of Engineers, and a whole host of others in terms of some of the things we're about to talk about. In thinking through this, and from what you've heard, this talk is going to really try to help build this bridge between risk and resilience. And we're going to talk about what that really means practically, and what it means when one tries to implement something around which there's great uncertainty. So there's the $1 billion weather and climate disasters from the National Centers for Environmental Information. Flooding, wildfires, winter storms, tropical cyclones. I always have an argument with them over drought and heat waves because it shows up with a lot of mortality, about the third of the amount of severe storms. But the only impacts that are actually on there on drought are insured losses, not really all the losses to water resources, to tourism, and all these other things. And as you could tell, severe local storms, tropical cyclones, there's the belt, we're in that. And a lot of this information gets used. Whether or not we like how it's used is a different thing. There's the quote from Mark, Munich Re, North America. NCI data is invaluable to reinsurance. It's hard to put a tag on it. There's a financial sector. Without it, we would lose billions of dollars in economic activity in the US. So what does this all mean in the context of the uncertainties and the knowledge we just have described, and how we move ahead in thinking through adapting in a changing world? So the question fundamentally is, given extremes, given trends, given variability, we have many potential futures. And adaptation requires science that assesses dynamic risks, analyzes decisions, identifies vulnerabilities, improve foresight, develop practical options. Or as my advisor, a guy by the name of Herbert Real, said once coming out of a talk, he said, it's good to see old results in color. The idea, then do it all again. All right? So let's think through this. Which pathway should we take, based on what information, given what we've seen, with what consequences, and when, the most fundamental question in adaptation, when should we change our assumptions? The built environment, I was one of the convening lead authors on the adaptation chapter for the National Climate Assessment. There are cascading consequences of heavy rainfall for urban systems, combined sewer system failures, untreated overflows into rivers, exposure to waterborne diseases, closed roads. I show this slide to give us a sense of where we're going in terms of this link between risk and resilience. In many cases, when we talk about risk, we talk about a single event or type of event impacting a particular resource or the management of a resource. I work on Western water issues, managing reservoirs. But if you ask the fundamental question about resilience, which is, should that reservoir be there? That's a different kind of question. When you ask, what are the multipliers of impacts of these events? then it begins to get more complicated. So we have some examples around the country of where, since the last assessment, we've tried to improve not only our assessment of impacts, but also the actions. And I'm going to address a few of these within the talk. But before we do that, I'm going to show some stuff that we've done in the Caribbean from the standpoint of what impacts we've seen and where this link between risk and resilience is being taken up. So we like to think of the Caribbean islands. I usually show it a lot bigger than that. I grew up in this little island down in the south here, Trinidad. Archipelagos, high islands, single islands, very different geomorphological and geologic structures. So they are impacted very differently by the biogeography, by the economic and social units. But we know what happened before, after Maria. In 2017, 22 of 29 Caribbean small states were impacted. 4 affected by 1 storm, 13 by 2 storms, and 5 by 3 storms. The reason why I like to start with cases and not large N studies is large Ns do not help us understand the impacts of extremes very well. They actually, when we try to aggregate over too many numbers that are sometimes incommensurable, we get relationships that are actually confounded in practice. So if we look at what has come out of some of these, we'll ask, well, here are some of the impacts. There's Hurricane Maria, the surface wind speeds. This is a nice study by Kishore. There's 125 days after the impact, the loss of basic utilities, water, cell coverage, electricity, the disruption of medical services, and household recovery, unable to have dialysis, up to unable to get medicine. Number of days without basic services. So critical systems and failures caused evacuations, closures, and reduced services. As many people, Walt Peacock, who is a sociologist, did some great work after Hurricane Andrew, showing the community that was able to get aid last in Hurricane Andrew was single female heads of households because they're not pushy and they're more worried about issues surrounding nutrition before they go to line up to get aid. The other types of issues that surrounded that were understanding very well that during the hurricane, the medical facilities were reinforced, but the transportation systems to get doctors and nurses to the medical systems were not. So when we begin to think about risk and resilience, we have to think, yes, the likelihood of the event, the likelihood and consequence, but much more about what's the network that supports those effective responses when we see hurricane changes. From simple risks to complicated risks, and this is from the special report on extremes, complex and compounding and cascading. We can model some of these, and we do a lot of integrated assessment models to help us think about how some of these are interacting, but they can't be used for decision-making in practice. What else did we see? In the Caribbean, from 2013 to 2016, the multi-year drought was the most severe and extensive period of dry conditions since 1950. So we had a big period of drought, then a hurricane season of immense proportions affecting multiple countries at the same time. So if we're thinking about where this is going, this isn't attributing anything to anybody or anything else, just saying even the complicated nature of addressing sequences from droughts to floods are becoming more and more problematic for the adaptive capacity of not just small island states, but for countries themselves. There are also increases in potential evapotranspiration that we're seeing, and we've developed an index, the evaporative demand index, to try to get us a sense of how thirsty the atmosphere is getting over some of these regions. So what was happening? An early warning and capacity building system was actually put into place prior to 2017. It was sector specific. It was a consortium of the Caribbean Institute for Met and Hydrology. It was the University of the West Indies, and they produced a regional consortium with the Caribbean Public Health Agency, with the Caribbean Disaster Emergency Center, with Southern Command. And basically, we can show that in spite of how critical, even in places like Dominica that were completely decimated, that lives were saved by having this system in place long before the 2017 hurricane. Now, this is important because it tells us that early warning has a big impact, but it also tells us that early warning without the capacity building surrounding these agencies and their partners does not work if we do not have the networks that are built up there. So what else is happening in this region? After Hurricane Ivan, which had basically destroyed Grenada, CARICOM Heads of Government approached the World Bank for assistance. And Munich Swiss Re actually offered the payout to create something called the Caribbean Catastrophic Risk Insurance Facility. The base for the CRIF, as we call it, is the NOAA hurricane model. Basically, it produces the threshold winds from which these things are applied. I helped develop the background for some of this. The total payout since 2007 was about $120 million. Immediately after Irma and Maria, so $31 million and 24 payout. That's not a whole lot of money compared to what was lost because the basis risk, i.e. what is lost versus what is insured, is not paid out. But it was enough that these countries could restart their capabilities, repair their ports, and start back actually fixing the facilities for trade in water. This is an important issue. This is how we're beginning to think as we move through a changing environment that we cannot specify the risk and the losses a priori, but we actually have to get a sense of where things are being spent in the budget, the post-event activities. Any estimate across the US and in the world, what percent of our budget do we spend on mitigating disaster risk before the event? What's the percent about? Right? So if you add a 1 to it, it's about that. It's about 10%. Everybody knows we should be preparing. We spend about 10% preparing. As I always like to tell people, there are good reasons for that. I tell them, if you want to be proactive, sure, I agree, you first. Because it implies an upfront cost. No matter how many times we talk about, science, information produces foresight. Yeah, not if you have to bear the risk of taking that decision. So let's think through what some of this means. This is the world's first regional risk pooling fund issuing parametric insurance. Really, really good case. But something as important to those two, the early warning and the insurance, was happening. The Caribbean Climate Change Center, the University of the West Indies Regional Strategic Framework, started to do a series of studies around the region that we helped them with. I told the University of the West Indies. We have a network of people doing new water system design, PV systems, agroforestry. These were the things that allowed the capacity of people to be able to use that early warning information. So without those three pieces of the insurance, the early warning system design for integrated information, and the capacity building and vulnerability assessments, we would not have the three pieces that produces long-term resilience. That doesn't mean disasters don't happen, right? Our definition of disaster is not the event itself, but the inability of a community to manage its own risk. When it goes outside of their capability, then we have a disaster. But what are we seeing? In this region, we're moving in the Caribbean from an area of unfamiliarity to unprecedented changes in terms of damages and impacts relative to dryness and drought. We were just talking about this. I think Tom and I were talking. We know a lot about, and we know that the Caribbean region faces risk from hurricanes. A lesser understood issue is that the major risk to the economies of the Caribbean is water supply. During the tourism season, Jamaica uses 10 times the amount of water that it gets from rainfall each year, mainly pulling it from groundwater and elsewhere. That tells you something about the vulnerability of these systems. So as we begin to think through what constitutes resilience, moving from the unfamiliar to the unprecedented, we did a set of scenarios. There's our cool running scenarios, moderate growth, individualism, consumerism. There's our islands in the sun scenario that we did with communities around the region, renewable energies, and with governments. There's the harder they come scenario. Right? Jimmy Cliff, anybody know, right? Of course, people are too old to remember that. All right. And there's Pirates of the Caribbean. So as we think through these futures, that's the wild card. Global economic changes, globally networked risks, the imports and exports that come into this region. Narcotic trade, a big issue happening right now that is driving these four. So there you go, 4.5, cool runnings, island in the sun. So we're moving, and we have a better sense of how to manage the risk from the early warning systems, from the insurance, and from vulnerability, but not when we're moving into these surprises within the system. So if it's so easy to identify the problems, why is it so hard? I like to put this up. There's the Dreadnought-class starship. We understand the risk. We can build it, right? The Klingons are coming. We know what they look like. We can design the perfect ship called risk assessment. Well, meet the Borg. The Borg is where resilience matters because we do not have the design capability to prepare for it. So we're going to manage through it, through new knowledge and through new areas. Mark Kane's doing a lot of work on conflict issues. They don't arise from just large end studies. It's completely context-based. That's the trade-off between risk and resilience and what we need to know to bridge these two. So what's a rational risk assessment model? We identify the objectives, we identify the alternative courses, we evaluate the possible consequences of each alternative and select the alternative that maximizes that attainment. So it looks very rational, makes for a ton of good academic papers that aren't used in practice, but hey, that's not the goal. Predict the possible consequences of each alternative. Well, that sounds good, right? What we ought to do, predict the possible consequences of each alternative. And we'll do that successfully. As I like to tell people, success in the business of uncertainty is 95% luck, 3% skill, 2% persistence, and 1% attention to detail. All right. If we only knew the costs, that's what's stopping us. Here's the Financial Times. I gave this section of a talk at the OECD ministers meeting a couple of years ago in Paris and said, oh yeah, we need to know the cost. All right. Revenue produced by using an acre-foot of water for alfalfa is $920, for lettuce, $6,000. Intel to manufacture 2 chips costs $13 million. We know the cost, but where's the water going to these two things, right? So it's not just cost. This is a study done by a natural hazard group under FEMA funding. I was one of the reviewers of it. The wildland-urban interface, $1 of investment saves about 4, 1 in 5 for wind, 1 in about 7 for riverine flood, 1 in 7 for hurricane surge, based on land use, and a study we did years ago basically showing land use planning has the biggest cost-benefit ratio, but we do spend the most money just on retrofitting. So is it really the cost? Is it not knowing the cost or knowing the benefit that's stopping us? No, it is other things, right? Here's something we've had. This is a figure in the National Assessment Report. First pulled together by Peter Rogers, Peter Glick, and then we did the analysis behind it. There's US water withdrawals that have leveled off since about 1975. The US GDP doesn't show a blip. A very famous person once said, oh, conservation, that may be immoral, but it's no way to plan a future. This is basically conservation, right? We're using less water in total in the United States, and it does not show up in the economic value or loss from efficient technology, behavioral changes, showing no loss of economic competitiveness. This is an interesting figure, simply because it says that the upfront value of things we put into place now has near-term value. That's a really, really important thing, because so much of our hold off on adaptation is somewhere in the future. Well, your future, not mine, right? So how do we think through some of this? And the efforts to do adaptation do not always require major investments. It's interesting, we just heard from the village of Biscayne on climate resilience officer. The climate resilience officer of Baltimore is the person that really put this into place, Christian Baja, right? Adaptations do not always require major investment. Oh, if we could only assess future risk. I need to show just one slide. This slide, do we really need to know where this risk is going? How well do we need to know the future? There's that map. As the old Chinese proverb said, if you're not careful, you'll end up where you're going. That's where we're going. Predict, then act methods can backfire in deeply uncertain conditions. That doesn't mean we do not need to predict or understand the dynamics of prediction and indeterminacy. What conditions will be under those conditions? How sensitive are those decisions to those conditions? The uncertainties are underestimated. They're competing analysis. And there's misplaced concreteness. Even Nostradamus would say, I didn't see that coming. The idea here is not that we're not engaged in prediction. It's just we need to work and manage and predict our way through the future with the full understanding that we're not able to predict everything. And characterizing the uncertainty is a formal part of science, characterizing the indeterminacy. But our papers do not allow us to talk about indeterminacy, because it says we're not as optimistic about the future in terms of our predictions. Yet we need to have the papers tell us about that. So if only we get the communication right. The push of new information is bigger than two-way communication. More challenging is understanding the socialization of lessons learned by people as they go through their own direct trial and error experiences. As you heard in the village, recognize communication as critical but not sufficient. There's the preferred forms of communication at work: sighing, glaring, yelling over cubicles, animated GIFs, emojis, and here are meetings. An important one when we're thinking through this are mental models and cognitive distance. Baruch Fischoff, a name to conjure with in cognitive psychology, could tell you a whole lot about mental models. Right? There's a whole slew of ways of thinking about this. We know that effective projects ensure targeted communities fully participate. But there's something called the construal level, the difference between people who ask how and the people who ask why. And for a long time, between science and practice, there's a lot of distance between what is being provided and what is being asked for, and the space in which we ask that question. It's one of the reasons why NOAA, Claudia Nierenberg, myself, and others created something called the Regional Integrated Sciences and Assessment. Physical and social scientists working on what makes for better decisions. Not just what makes for better use of information, but what makes for better decisions. As I like to tell people, we shouldn't be in the business of helping people make the wrong decision with better data. As Galileo said to the Doge, I think they should go over well. I'm sure one of them was on the small end of the construal level and one on the large. So what is the message? In the context of a changing climate, despite advances to date, future hydroclimate variables will remain a major challenge, but we are getting there. Nature is complex, whoopee. Reliability, but the long-term and sustained observation programs are critical, especially for verification. We need to avoid pursuing spurious certitudes through spurious rigor. Bringing n number of models that have some of the same weaknesses to a problem does not create a large n situation. This is where cases matter, right? There's a distinction between spurious rigor and spurious certitude. Factoring resiliency into system design and planning is still the safest approach. What do we want? Evidence-based change. And when do we want it? After peer review. But let's not wait too long. So how do we put these pieces together? The economies, communities, environment, all of these little pieces. We need to focus on characterizing the drivers, a lot of what we just heard. Stop me when I have another 40 minutes to go. Yeah. Challenges. Many impacts are difficult to quantify. Many events produce little immediate mortality. Quantification of long-term mortality and excess death is complex. Baseline data may not exist for metrics. Under health, most published literature describes single events and single healthcare facilities. This is why it's hard to get good data that is as reliable as the physical data on the social side. So what do we do to think through it? Need the quantitative examination of trends and the cases across a large number to understand both the dynamics and the context. Many different views bring us to that. Here's one example I like to show. This is an old figure. The importance of factors shaping health: behavior, socioeconomic conditions, environment, genetics, healthcare. The environment comes out at 10 to 20% until we begin to ask, how does it now influence all of these pieces? These types of estimates need revision and need work in terms of how the environment is influencing all of these areas and how we influence the environment. Focus on adaptive capacity and improving decisions. This figures in the National Climate Assessment. We go through cycles of awareness, assessment, planning, implementation, monitoring, and evaluation. Some people might call this the hydrological cycle. The idea is, what creates learning as we go through assessment, planning, and implementation? In 2014, for the national assessment, we were about in the planning stage. By 2018, we had a few things in place, but as a society, these are just postage stamps. These are just examples and prototypes, not a way of thinking about adaptation over time. And focus on integrated weather risk governance. Broaden the actor network from ensuring the authority and coherence, the culture of partnerships, decentralization. But there's a whole issue surrounding this issue of co-production that I'll just mention. Partners do not just share data, they also share risks and responsibilities. The most important thing for us to be doing here is arrangements for iterative individual and community-based learning. The types of things that the University of Miami and others are trying to set up by creating integrated knowledge centers. But it has to be managed in this way as opposed to thinking about one piece of this as solving the problem. So I begin to wrap up. I'm not actually wrapping up. I like to say that the moderator gets excited and thinks something's happening. Society has limited resources to help individuals and community adapt. How do we invest? This is a figure we drew at IBM, AECOM, national agencies. We go from multi-decades, decades down to subseasonal to seasonal. A lot of different decisions. A lot of successes are taking place. Early warning systems are saving lives. We hear a lot of Hurricane Dorian, 150 miles off the coast, didn't have to do a major evacuation. There are successes, even though the impacts in the Bahamas itself was devastating. In better dryland farming, and these are all concrete cases where investments have allowed us to make better decisions. But the most important thing is the upfront costs are only part of the problem. A really good study by Stefan Halget from the World Bank said the annual cost of infrastructure disruption as we go through time is actually some of the major costs. So where should we invest? The liquidity gap we have is between emergency assistance and long-term infrastructure and development. And we're advocating with the World Bank and with others that we actually focus on this subseasonal to seasonal timescale, strangely enough, where the liquidity gap actually occurs, where you can get at the emergency response while putting into place long-term planning. How good are humans about using information about the future, the long term? Not very good. We're really not very good at that. It's not how we plan. We plan from event to event, we learn, and we rebuild. So from resilience to efficiency, there's our current system. We want to design to maximize efficiency, but really, we need the course constructs that cost the design phase for maximizing resilience. This figure we drew in a paper in the Journal of Risk Analysis on where resilience lies versus the known and quantifiable threats. An old Native American gentleman always told me, he says, uncertainty is not what you don't know, it is what you know that is no longer true. And you heard that in the previous talk. The cues that we're coming to understand are changing. But what do? We can't assume some stable future. So the best metrics approach we're advocating is this physical, information, cognitive, and social. Understanding each of these across the cycle as we go from event to event and preparing, absorbing, recovering, and adapting. And this is in our paper in risk analysis from the neighborhood to the country. But there are some caveats. We hear a lot about co-production. It's a useful concept. But what we're seeing more and more is that those who already have power and technological sophistication are the ones who are driving it. And communications is not enough. The factors that give rise to human insecurity are not simply amenable to better communication. And the request for information is a symbolic commitment to the rational. James March always said, the famous organizational psychologist said, people will ask you for information because it looks rational, not because they plan to use it. So, to end, there's the bridge at Avignon, the famous one. We need this risk to resilience bridge. It's not yet complete. The challenge of integrated knowledge is sustaining the collaborative networks across research, observation, services, and decision-making, and having all of these people move, all these components move together at once. As was said, we each have one of these parts. As people in the room are familiar with the for want of a better word, the sixth sight impairment and the elephant, right? Everybody taught some piece. What's the corollary? 6 blind elephants will conclude a human being is flat, right? We would use the same models, we'll bring to bear the information, we'll agree on the analysis, but we'd all be wrong. So these types of storms are going to be more frequent now that we store data in the clouds. Thank you.
Okay.
So all of this, we have the reports and papers. These are all empirically based. So.
Right. We'll be able to get a list of your papers from you.
Yeah.
Questions for Roger?
Yes?
Yes.
Hi, good morning. John Morales from NBC6 here in Miami.
Oh, yeah.
Hi. So Abacos, Floyd 99, and Dorian
Yeah.
2019. And Kerry Emanuel's studies on the return period towards the end of the 21st century showing much shorter return periods. For example, Maria, instead of a 1 in 200-year event, could be a 1 in 20-year event.
Yeah.
So as you talk about investing in mitigation for more resilience, I mean, how does a society do that? I mean, if you invest in mitigation, that's less money for education, less money for infrastructure,
right. It's
less
an
money
upfront
for
cost.
government services.
It's an upfront cost. Yeah.
Right. I mean, so I guess just general comments on that conundrum.
Yeah. So one of the reasons I showed that figure about where the environment filters into our socioeconomics and where it filters into our behavior and our perception is whether or not we understand the extent to which investing in staving off the impact of let's say, events that are closer in sequence, are actually affecting the recovery that we have to do and spend on for the very things that you're talking about. That trade-off, even though we describe it, is not well understood. As I've mentioned, there are lots of good quantitative studies showing, on average, $1 now saves $4 to $5. But we have to show that it saves it in the next event. If we do not, then we're amortizing that benefit over into the future. And the moment we put things too far into the future, we toss it out, because that's not how human beings plan, right? So what we want to be able to do is describe why sustaining the very capabilities and the networks, the education system, things like that, are actually benefiting from this investment. And the reason is we usually think of the recovery and the emergency response mode, and not this liquidity gap that says, you know what, you're protecting your investments in all those other areas if you spend that money now. But you're not benefiting from it sometime in 2050. You're benefiting from it the next season. That's actually in the Caribbean, those three things that are put into place with the CIMH, with the bank and so on. That's the only way we got it funded, to be able to be upfront. Now there's something else. Every community has to decide what constitutes its acceptable level of risk, the amount that it is willing to purchase or put their citizens at risk. That is not transparent. That is actually not transparent to many of our coastal communities and to many of our water systems throughout the US. So our fundamental question is not simply that it makes for a hard choice. If we spend the time thinking about it, we can actually show where you can make money planning up front. And that's the key part of what we're showing. That whole issue with the water system, and I have a similar figure for energy. We're leveling off in the total use, and you cannot see a blip in the GDP. Yet, if we ask that question to anyone, they'll say, no, I mean, upfront stuff like that is costing me my well-being. So that's one thing. On the other issue is basically saying that all of those investments in what we call absolute goods, health, water resources, human welfare, that this is on the level of that absolute good, because it's protecting that good. In economics, you call it, or in policy, really, you call it an absolute good because it is a fundamental good to the human condition, things like education. As I like to say when I do testimonies, I always like when I do an interview afterwards, I said, that was a hearing, not a listening. You've got to make a distinction between the two. And unless we're able to say that the level of planning we're talking about is an absolute good fundamental to human well-being in place, then we're not making the case that you're saying. It will always be seen to be an add-on,
Okay, I think we still have 30 minutes of talks before lunch.
Well, hello.
But we are going to bring Roger back up along with the other speakers from this morning in a moderated discussion this afternoon, in case you didn't know that.
I moderate to the extreme.
Okay.
Yes. Okay.